Okay, so in the last hour or so, we're going to go through, I'm going to start off just talking about our GitHub. I think we've said GitHub a lot, and I don't know if anybody knows where to find it or where to go. So what we've done in the past year is we wanted to be better about our CDM version control because we have proposals where it's constantly changing, people are making it better, but we wanted to make sure that we were all on the same page with it as we did so. So if you go to github.com/OHDSI, you'll find all of our GitHub repositories related to the common data model and all of our tools and everything that everyone's working on. But if you specifically go to the common data model repository, you will find all of the code related to the common data model. And this code is everything that's been written in multiple different dialects to get these tables up in your system. So you don't have to go write them yourself. Like, don't worry, it's already all been done. Can you go to the link, Erica? That's okay. So, we will be giving you these slides as you leave today. You'll get an email from us with all the slides. But you probably want all this information at your fingertips about the tables, the conventions, all that kind of stuff, because there's no way we can remember it all. So if you go to the GitHub page, there is a tab up there called Wiki, and in the Wiki is all the information related to our most current release, which is version 5.2. And then on the front page of the GitHub, you also see our release notes, things that have been changed. And if you look in the issue log, you'll see all the proposals that are out there for additions to the data model, changes to the data model, changes to conventions, to the vocab, what have you. And so please feel free to go out there, add your 2 cents, add an issue if you see something that needs to be changed for your use case. Please bring it on. We're welcome and open to everyone. And we also, in doing so, we get together once a month in our working group to discuss the current proposals. And so we have a wiki page on odyssey.org that has all the information. We meet the first Tuesday of every month after the larger Odyssey call, and all that information is out on the wiki page as well. So fortunately I can't show it to you, but you guys can find it. I trust you. And if you have more information, if you want more information, you can contact me and I can kind of help you get started and let you know where to go to find this information. And if you need help with a proposal, I can help you with all that kind of stuff. That's about it. I think this is all you, right, Erica?
Okay, so final stretch. Turn myself on, and I will steal the clicker from you. Okay, final stretch. We're almost done. You guys have survived this long, so we're doing good so far. So we spent the morning talking about the vocabulary, and then we just recently went through the CDM. So this last part is to make the actually getting data out of the CDM a little bit more tangible. And so you guys all had the painful homework of getting the VM working on your machine. Some of you guys are using the online version that was set up as well. But what Karthik talked a little bit about this morning, that VM that you've downloaded is called Odyssey in the Box. And the whole point of Odyssey in the Box is basically to give you a computer on your machine that's already set up with everything. So at your company or your organization, you don't need to have Atlas running. You don't need to have a Postgres database or any kind of database. And so if you're completely new, this gives you an opportunity to play. So you've already experienced that a little bit this morning with doing the queries, and so we're going to keep moving forward. But so you're probably wondering, well, what is the CDM that this VM comes from? So I think everybody's very familiar in our line of work that it's really hard to share data. But fortunately, a couple years ago, CMS came out with a data set called SynPUF. And it is a synthetically generated database. So we can all share it. We can all play with it. And the whole point of CMS creating this data source is for people to learn and get experience with claims data, especially in the situation where they don't have any access. And so, again, it's synthetic. You cannot perform analysis on this. In fact, if you actually look at the data, there's a lot of congestive heart failure, more than any population would have. And it looks really funky if you kind of graph things out, but it still gives you a sense of what a claims database is. Now I know not everybody's from the US, so it is a Medicare claims database, which in the US, this is a government insurance for primarily people who are over the age of 65. There are some people who are in Medicaid who have disabilities as well, but it's the majority of the patients who receive this type of insurance are over the age of 65. And we have taken this database and converted it to the common data model. So the actual raw data is fairly simple. There's only 5 tables. So there's a benefit summary table. This table is going to tell you a little bit about the person. So what's the gender, when were they born? They actually provide summary information like what's the AIDS status of this person. So there's a good amount of fields that are associated with each person. Then there are 4 tables that are describing events that happen to this person. So inpatient claims. In the United States, this is when you go into the hospital, you're probably staying overnight, and that's an inpatient claim. An outpatient claim, when you go see your doctor, maybe you have a cold, and you go in and you leave that same day. Carrier claims, these are usually, they're called physician claims. So this is if I go to the hospital, the physician's not associated with the hospital, but they still want to get paid, they'll submit a carrier claim in order to do that. And then last, prescription drug events. In the United States, this is like if I go to a CVS and I go and pick up a prescription, that's going to generate a claim in order to get reimbursement. So if you're like me and you like to think in pictures, this is how this database is laid out. I have a primary table that tells me about my people, the benefit summary table, and then I have these 4 tables that are going to tell me about these patients. Mui just explained earlier, if you have a really healthy patient, they might not have any other claim information. They might just have a benefit summary record. Now, given that this is a greater than 65 population, there's probably records for most of our patients in here. So like I said, we've already done the work here and converted this into the common data model. All the work that was done around this is on the GitHub. So everything from the documentation that we produced, how we produced the documentation, and the actual program that takes the raw data files and converts it to the common data model. So the whole process of getting from raw data to the actual CDM is freely available online, and is also a resource for you to learn how do you go from raw to CDM. Okay, so now we're going to do some more examples. So similar to this morning, we're going to go and look for some drugs, but the twist here is we need to figure out where the drugs are. So we've talked a lot about warfarin today, but warfarin's a blood thinner if you don't know already, but we've been talking about it all day. And so in the CDM, where are we going to find exposures to warfarin? Does anybody remember? Okay, people have been listening. This is wonderful. So yes, if we're going to go and look for drug exposures, it's going to be in the drug exposure table. And typically in the OMOP common data model, when we're thinking about exposures, this is drugs that the patients have actually ingested. And that's kind of how we think about it, that there's actually exposure, or we believe that there has been exposure. So we've talked a lot about today that when we convert our data from the common data model, from the raw data to the common data model, the whole point of this is for us to stop thinking in source codes. So if I'm in the United States, I might be used to thinking about warfarin and NDCs. We don't want to be thinking about that anymore. We want to be looking for the drugs using their concepts. And so this example is going to hopefully help solidify how we're going to get that. Okay, so how do I define warfarin? So we've learned already today that we can write SQL queries in the vocabulary to define the concepts that we want to find warfarin within our database. So we've kind of covered that part already. You've probably been hearing the word atlas thrown around. I know not everybody has the same experience, but there is a web application called Atlas. And the whole point of Atlas is to give you a web interface to actually try to help find concepts for a drug like warfarin. So we recognize that not everybody is going to be writing SQL queries, and a tool like Atlas makes that a little bit easier to do. We believe in these tutorials we want you to be writing the queries. That makes it a little bit better. It helps you remember. But really, a lot of people are probably going to be using Atlas day to day. But in this tutorial, we're not going to touch too much on Atlas. So I think you guys are experts now about getting into your box, but just as a reminder, we're going to open our PG admin again. We're going to connect to the Postgres database like we did this morning, and then we're going to get into the public schema. Now, in the second homework I sent you guys, there was that SQL file. This is the part of the tutorial where we're going to use that SQL file. So you can actually open that up in Notepad++ or whatever your favorite text editor is, and then we're going to actually copy and paste that into Postgres. So I'll give you guys a few seconds to open the file and do the copy and paste. If you're having trouble copying and pasting, let us know. Do you have a question?
Do you want to copy and paste one statement at a time?
You can copy the whole thing, and then we could just run each statement. You just highlight a statement and then hit the play button.
Oh, okay.
Yeah. Or you can do whatever you want.
I didn't realize you could do that.
Yeah, you can copy. Yeah, copy from exercise 0 down.
And for those that are on the cloud version, the file is actually on the document directory. So you can take that and copy and paste it.
Is the file in the VM in the box?
The file's not on the box this year. It was sent in an email, in that email. But if somebody doesn't have it, we also have it on the drives that MUI has. Is anybody missing it?
Anyone missing it?
Okay.
I'll go.
Okay.
Let's see if we can get a thumb drive.
Thank you. Okay, I know we're getting set up, but I don't want to lose you guys, and we don't have that much time left. So if you have the file, copy and paste it into your Postgres window. Let's run this first example. So in this first example, what we're doing is we're going to ask the drug exposure table, can I find the drug concept ID for this ingredient? Now this morning, Christian did a lot of talking about the ingredient for warfarin, and so this is actually the concept ID for the ingredient. And so we're going to see, does the drug exposure, how many patients have exposures to the ingredient? So when you guys run it, let me know what the answer is. Okay. So okay, does anybody know, can anybody think of why the answer in this case might be 0? Huh? No, that's a good idea, but in this case we're using concept IDs, so the integer doesn't care if it's still a number. Does anybody have any other guesses of why we didn't find anybody? Okay, so what was just said is that in the raw data is storing exposures to products, not to ingredients. Now, that doesn't mean that all data sets are like that. Some data sets might come across only with the ingredients, but in this data set, it's NDCs, and NDCs are going to say things like warfarin 50 milligrams, and that's the level that it's storing. So how do we find that? You guys doing okay? Okay, so let's run the next one. So in this case, what I'm going to say is I want all concept IDs that are associated with the ingredient warfarin. So in this case, I'm going to use my concept ancestor table to help me go from the ingredient to all the RX norm concepts that are associated to that. So again, Christian said ingredients are ancestors, and then the more specific concept are the descendants. And that's what I'm using this inner query here. And so how many patients do we get when we run this query? Hopefully the answer is not still 0. Yes. Okay, so and exactly for that right idea, now that we're pulling in concepts that are at the lower levels, we're actually pulling back the exposures that exist within the drug exposure table. Okay. Let's broaden this a little bit. So sometimes you might be asked the question, I want to find anticoagulants. So I don't care which anticoagulant, I want to find them all. And earlier today we learned that there's the classification hierarchies. And so you can use those classification hierarchies to say, I don't want just warfarin, I want everything that's an anticoagulant. In this case, there's a VA classification. I'm using that one, and I've said, okay, using this concept ID, I want to find all the descendants. And so this is going to include more than just warfarin. So we would expect more patients, right? So how many patients do we get when we run this query? Yes. I got my A student in the front. Is everybody doing okay? I know I hear lots of chatter. Or Mila, are you doing okay? Okay. Okay. I'm going to keep going unless people complain. Okay. Now we're going to go to, let's try to find new users of warfarin. So now I need to do a little bit of explaining before we go and try to find this. So I guess first, if you guys have noticed all day throughout this slide, I have put in these little pushins, or we have all put in these little pushins. So pushin is our mascot for the day. I'm sorry, I torture everybody with the cat, but I think cats make things fun. So, but let's, if we're trying to define new users of warfarin, how do we actually think about this? So I work at Johnson & Johnson, so we're doing a lot of things within the drug safety perspective. And so when we're doing any type of research, we're usually looking for new users of warfarin. So how do you think about this? And we usually think about this by saying, when I find the first exposure for a person, I want to have some type of washout window before that exposure, so I know a little bit of something about that patient before the exposure. And that's what we think of when we think of a new user. And a lot of cohorts are designed in this way. There's definitely reasons why you might not do it, but a lot of the research that we do at J&J, this is how you're going to look for a new user. So let's say Pushin is starting to take some drug, and Pushin's lifespan is from 2007 to 2015. And between the years 2011 and to the start of 2014, Pushin was taking this drug. But usually within our databases, we don't see all of Pushin's record. We only see a snippet. So in this case, in our database, we only know about Pushin from the years 2013 to 2014. So if I go and say, when was the first exposure to warfarin for Pushin, we would think it's in 2013. So where this becomes a problem is it really wasn't the first exposure for Pushin and we don't know anything about the patient before the exposure. So if we need to characterize the patient prior to exposure, we're not going to be able to do anything with this record. What we would rather is if we had Pushin's record from 2009 to 2014, we actually know something about this person before the first exposure. So not only can we look at their characteristics prior to the first exposure, we also feel confident that they weren't taking the drug before. And this concept of new users this is how this kind of plays out within observational data. A lot of times, and I even think yesterday in the presentations, you see these depictions in order to help us explain like how did the parts of the query when we're defining a cohort play out. And in fact, a lot of times when we're submitting manuscripts, we represent cohorts in this way. So in this case, we have our index drug, and we're looking for that washout period for the patient. Okay, so if we're going to try to do this, we've learned this morning about using the vocabulary. We just looked at the drug exposure. So now if we want to know something about time, we need to use the observation period table. So that's the next part that we're going to add into this equation. So in your SQL, you have this example query, but I'm going to walk through it for you. So first thing, we just did this earlier. This is the vocabulary lookup. So this is going to get, just like we did before, going to find all the concepts IDs for warfarin. And just like we did before, we're going to say I want to go to the drug exposure and find those find all those exposures. But the part that's different is we need to add in the observation period table. And so in this case, what we're going to do is when we find the drug exposures, we now have a person ID associated with those drug exposures. So for those persons, I need to go find their observation periods. So in order to join to that table, I need to do it on the person ID, which is this part here. But additionally, a single person can have multiple observation periods. So I need to use my index state to figure out, well, which observation period that I mean. So especially in the US claims system, I could be in Aetna for 2 years. I could leave for 3 years, and then I can come back for 2 years. So my data is good, but I need to understand that there's a gap there. And that's what the observation period tells us. And once we connect our observation period table to the rest of our query, I can then just say, well, given my index date, if I subtract it from the observation period start date, I want to make sure that's greater than 180 days. And that's giving me my washout period. OK, so if you guys run that, what do you get? Is there a question back there?
So do we really need to use the observation period table, because in the drug exposure, we already have drug start and end time, right?
Mm-hmm.
And so why do we need to be observation?
That's a good question. So the question is, how are we using the observation period table, given that we have information about the drugs in the drug exposure table? Do I got that right? So observation period table, and this kind of goes back to our observation period tables telling you what time you have for your patient. So if, in this case, the observation period for this patient is going to go from January 1st, 2009 to December 31st, 2014. That's the observation period. And why we're using it is to tell us a little bit something about how much do we know about this patient. So if you want to do new user, if you want to say, I want to have time before first exposure, the observation period table tells you that. The observation period table doesn't tell you how long you're exposed to a drug. The drug exposure start and end date is telling you about that individual exposure. Is that clear?
Yeah, but observation, the information you pull can only based on the patient in your data system, right? If the patient may be healthy or weak, but
yeah, so, but each drug exposure is about a patient. So you're matching your drug exposure per patient to their observation period. But we could talk about it more if you want. Okay. Are there any other questions? Did anybody get the answer? What's the answer? Okay, good. Yeah, okay. Okay, perfect. Okay, so we're going to just keep making it a little bit more complex. So in this case, we're going to add in an age requirement. Now, we talked that this is a Medicaid database, so most of these patients are a little Medicare database. So most of these patients are older anyway, but we're going to add in an age restriction just for fun. So, okay, so we want to find the older patients for instead of the anybody who's older than 65. So in order to do that, we need to now bring in another table. We need to bring in the person table. And that's because person table contains year of birth. It may have more. You may know the day of birth and the month of birth. But usually in most of our databases, we're lucky if we want at least the year of birth. And so that's usually how we're calculating age is the year of the event minus the year of birth. So in this case now, in order to calculate age, we need to pull in the person table. And so we're going to start with our previous query. The only difference here is I'm now going to join my person table. And just like with the observation period table, every person has a person record, so you need to use the person ID to connect those tables together. But when you're connecting person table, you don't need to do anything else. That's the only way that you connect to it. Because in the CDM, Every person should only have one record in the person table. Otherwise, you're breaking a rule of the CDM. And in this case, then, like I said, usually we only have year. So I need to extract the year from the index date, so whatever it was, 2014, and I'm going to subtract the year of birth to calculate an age. Okay? I have an A+ student right up here. So if you guys want to go ahead and run this. And yes. Is everybody doing okay so far? Okay. Okay. Exercise 3. You guys are really doing good. Okay, so now we're going to now just look at new users of warfarin. So we're going to use our observation period table still. We're going to get rid of the age requirement here. And then we're going to look for a prior atrial fibrillation. So sometimes in our cohort definitions, we want to look at certain people who have exposure to the drugs. A lot of drugs are used for different reasons, and so looking for a prior diagnosis of a disease helps zero in on the patient population that you're interested in. So in this case, what we're looking for is any time prior to the index, do I have that AFib diagnosis code? So in this case, we're going to need the condition occurrence table to help us with that. So in this, we're starting with our first query here, and this is putting our observation period in. That's giving us our washout period. We've already beaten to death at this point how to find warfarin, so off of the drug exposure table. But very similarly, we've been talking about defining drugs today, but we'd also need to define the conditions. Now, drugs I find are typically easier to define in the vocabulary. A lot of times when we're talking about drugs, it's easy to think about drugs in terms of ingredients. Conditions can be a little bit more muddy, and a definition can be fairly complex. For today, I'm keeping it simple in that I've picked a concept ID for atrial fibrillation, and I'm saying I want this concept ID and any of its children. In reality, when you're defining a disease, it's usually going to be more than one concept ID that's making up that definition. And actually, that's where Atlas is really good at kind of making that process of developing your concept set a little bit easier. But we're going to just keep it simple today. So that's going to give us all the codes just like we did for finding our drugs. But we're going to bounce that off the condition occurrence table. So just like with the other tables, the way to connect the tables usually is by the person ID. And so we need to make sure we connect through that. Now, this is a matter of opinion, and you could or could ignore this depending on how you look at it. Some people, when they say, I want a prior diagnosis of AFib, they say any time prior. I don't care if it's in another observation period. I want it any time. I like to stick within an observation period. So in this example here, what I've done is I've actually said, just like we did with the drug exposure and looking for observation period, I'm saying I want a condition that's in that same observation period. So for this patient, I'm going to stick to the observation period time and basically say that's the only thing I know about that patient. And people agree or disagree that that's how you should perform analysis. As long as you're specific in your documentation and your publication, it shouldn't matter, as long as people understand what you've done. And then in this case, I'm basically saying I just want a condition start date anytime before my index date. But I've bounded it already by my observation period. Is this clear? Does anybody have any questions about that?
Just a question about how you distinguish between a condition occurrence in a hospital or an outpatient. So in this one, if you only had hospital diagnosis, then you'd actually get a very sick population because they would have had to have gone to hospital for AF rather than. So depending on what data you had in your model, you get a different cohort.
Yeah, so that's a great question. So the question is, in the condition occurrence table, how can you tell if it's coming from an inpatient or an outpatient, long-term care or ER? And the way that you do that, and we're not doing it here, but the way that you do it is joining it with the visit occurrence table. So the visit occurrence contains one of those qualifiers. But you're right, if your data set only has inpatient records, then you're kind of already filtered to that. If your data set has a mix, then that visit occurrence ID is going to tell you what you're looking at. Sometimes even too, the visit type ID can give you some clues, but it's really, you'll end up in the visit occurrence table.
There are standards for research or for publication. So in my mind, it's a CMS HCC, how you can aggregate 12 months or rolling 6 months and get like this comorbidity condition category for like pre-treatment exposure or pre-treatment virus for like analysis. So when your team does this, are there measures for missing this, or what's the right window, and then what's the right frequency of encounters for outpatient to keep that in or pull it out for comparable groups? I'm just trying to.
Okay, I think I half understand your question.
It's a broad shot for causal inference from it.
So I think part of your question is how do you choose that washout window?
Kind of. I can follow up, but the idea is there a standard for the window before the drug hits? Is there?
So that's a really great question. And this is, I think, sometimes where Patrick gets rubbed the wrong way about how you think about it. Because I think the standard, at least at Janssen, we usually do this 6 month, 12 month, but there's probably not really good, it's not like, we've kind of pulled that out. I don't know if you want to, there's not real research to say, in this situation, do this. It's kind of.
The shorter you do, the less the less you really can say it's a new drug. The longer you do, the more patients you lose, because you just don't have patients who, even if they didn't take it, you don't see them that long. And then it's the argument that George used yesterday, if you do too long, then if you want 20 years, then you can't have anybody who's younger than 40 years. There's no science, it's just a convention.
Is an explicit propensity score assessment, like how matched the groups are for inference? Is there publications on that using potency?
But that's a different question to the washout, right? So you now change the question, right? Am I right?
I mean, I'm not sure what you mean by washout, which is my definition is not clear.
Isn't that what you were talking about?
I can follow later.
Okay. So the washout is how much time you require to have time before your first exposure. And since it's the first exposure, if you have time before, by definition, there is no exposure, which means there's a washout. There could be exposure somewhere before that. We don't know that, we can't see it. But we can say half a year before the first time you saw it, there's nothing. That means it's a new user, hasn't used it before. So now you have a nice index date where you can say he got it that moment, and everything which comes after I can attribute to the effect, and everything before you got it.
Yeah, so in that washout period, you're also creating a window for assessment of the pre-treatment covariance to make that inference, right? So that's what I'm going at. What's enough, and what's the frequency of information to meet that threshold?
Okay, so obviously this is now that tutorial, right? On that side of the wall. What you pick the covariates from that you believe will build you a good predictive model for whether or not you got the drug or not is also not precise science, and I don't think it matters really that much, because the model is going to pick those covariates which are predictive, because it's going to shrink it together, and they will explain to how much and how many, and how hard and what the method is for doing that. But the idea is you throw the kitchen sink and let the model do the work, rather than for you scratching your head a lot and think, and you having to figure out what are these biases and how are they going to influence everything, because that's a very hard thing to do.
Yeah, and I feel like we usually use a year unless we have a patient population where we know we're not going to get a year, where the year requirement is going to limit our cohort so much. That's kind of usually where we play with that 6 months versus a year. But like Christian said, it's not a magic number that was scientifically pulled out of somewhere. Okay. Any other questions? Okay, and so I already talked about this. Depending on who you talk to, will say how, if they care when that condition occurs. In fact, I think Atlas does not do this. Atlas will just look all time past. It just depends on maybe the epidemiologist you're working with. Oh, so think about, so the question is, should there be conditions before the observation period? In the scenario I'm thinking of is if I have a patient, but they have a prior observation period, that's not where my index is. So let's say they have 2 observation periods, your index is in the second, but they had AFib in the first. Depending on who you talk to, they may say, I don't care about that time. It's only this time that I care about for the patient. It's actually kind of an older school way of thinking, I think.
So is there a downside of picking that other population where, like, you define the index data and pick up the drug exposure for that and picking up all the people with diagnosis of atrial fibrillation even before that index date? So is there a downside of that? Because if you are limiting the diagnosis into this index period, you are losing a lot of cases, right?
Yeah, and so, yeah, I guess it depends who you talk to. So yes, the downside is we do, let's say the patient has AFib in that first observation period, we're kind of blinding ourselves to that if we do that. But the opposite side is you don't know what happens in that time between anyway. So the diagnosis could have been in that gap time. And so there could be other patients who don't have they had 2 observation periods. Are you going to come and correct me? But so it's kind of like a give or take there. So
they can give you a pacemaker and then the fibrillation is gone. And you didn't see it because there's the gap. So then the warfarin is not for the atrial fibrillation anymore. So that kind of thing. But there could be situations where that can't happen, and then it's okay what you're trying to do.
like for example, in our line of work, it's like if you've had cancer anywhere in your past, sometimes we don't care when it happened. You had cancer, we're certain of that, and that's serious enough. It depends on the situation, sometimes the epidemiologist. Okay, and so this is just going a little bit more into like, so this is where George's scenario that I was kind of highlighting, if the AFib isn't a prior, that depends on who you talk to, how you might want to do that.
I guess because EHR databases, they define the observation period by the earliest and the latest, so
Yeah.
there is only one, but in a claims database, you have multiple.
Yeah, so George was saying in a lot of EHRs, you don't have this, you don't have as much detailed time information as you do in the claims data sets. So usually the observation period is the start and the end for that patient. You don't know really where there are gaps. In claims data, you actually get a record for every month that the person is active in their insurance. And so you actually know when they've left the insurance. Okay, so I don't remember if we ran this. Did we run this? Yes. Okay, so do we have time? Yeah, we have time to do this. Okay, so you guys, oh, sorry, go ahead.
So, not a question, comment, whatever. So if you do this right, okay, you'll get like, you might be dealing with thousands, if not millions of records each month, okay?
Mm-hmm.
So somebody comes out and asks you a question, and you write out a SQL, and you get a data set, and you have no idea whether it's right or wrong. I mean, you look at the SQL here, it seems pretty straightforward, but you might be writing SQL that's 50 to 100 lines, okay?
Mm-hmm.
One little false move and you get a ton of data. But you have no idea. So do you have any pointers, comments on
Yes.
quality assurance, quality control, that kind of stuff?
So you would be best friends with Patrick Ryan because that's where Atlas comes in. So the belief that we have is that a lot of these queries, we're writing them in the same way, and there is a right and wrong way to write them. So for example, like there are certain times where you should always consider the observation period, and an analyst might forget to do the join, and then all of a sudden you might have a mistake. So where Patrick Ryan would say you should Atlas, if you define a cohort, and I'm going to show you an example after this section of kind of what that looks like in Atlas. But if you define the cohort in Atlas, it's going to write the SQL in a repeatable, standardized way. And you can actually pull the SQL out and look at it, and then you can use it in your programs if you prefer to do that. So for example, I do that often. I'll define my cohort in Atlas, get the SQL, and then I might parameterize it to run for 100 different cohorts. But I didn't write that beginning SQL. So I would say that's the standard best practice. Any other questions? Okay, these two queries should not be in your SQL file, but you have all the information to do this, and I believe in you. So the first thing that we're going to do is find Warfarin new users that have that prior atrial fibrillation, which is the exact last thing that we just did. All you're going to do is add in the person and try to add in that age requirement, which was also in a prior query, so you should be able to do it. Okay, guys, does anybody have the answer to either of these questions? Okay, guys, we're almost done. Just got to pay attention a little bit more. New Anthony. Hey, guys, got to bring it in just a little bit more. Has anybody got any of these? Yeah, we got the, for the Warfarin one, we got some people with it. Did anybody get the clopidogrel? Okay. So we didn't share the queries with you, but we're going to share them. So you're going to get email from Mara after this, and you'll have those queries as well if you want to see them. So, okay. So I know we said today is not really an Atlas tutorial, but I do think it's important for people to be thinking about Atlas. So actually the VM is running Atlas as well, so you'd be able to run this as but what I want to show you is that there is a way for me to create a cohort. And let's see if it's... Huh? No, it does. It works.
Not the ones that are on the cloud. The cloud one. Alice doesn't work on the cloud.
Oh, it doesn't. That's okay. It's okay. Yeah, so we're not going to be building this cohort together. I'm just going to be showing you what it looks like. Sorry, I didn't even start my VM today. Sorry, guys. I'll let that load, and I'll show you what it looks like in here. So, so Atlas is an online tool that you can essentially write the SQL queries that we've just been writing, but using a GUI interface. So there's lots of people who don't want to be writing SQL, and that's what Atlas lets us get around. And so what you can do is you're going to define concept sets. So you're going to define a concept set for Warfarin. You're going to define a concept set for atrial fibrillation, and then you can pull them into your cohort. So for example, here I'm saying I'm looking for patients with a drug exposure to Warfarin, but I want them to have continuous observation of 180 days. So that's our washout window that we were talking about before. I want them to be older than 65. And I want them, before their index date, I want them to have at least one atrial fibrillation. So actually, Atlas actually disagrees with me about where that atrial fibrillation should be. So usually it's looking all time prior. In this case, it actually doesn't end up making a material difference. But the reason I wanted to show you this is if you guys had done that previous example with the greater than 65 for the Warfarin patients, you can get the same exact number that you would have gotten by writing the SQL query. So like the great question from before, a lot of the research that we do internally in our shop is we're writing the cohorts in Atlas and then using the pieces that we need. So I'm going to see if I can actually show you really quickly what that looks like. Okay. Are you guys hovering for a reason? You hovering for a reason?
You have what for a reason?
No, never mind.
No, you don't, Google Chrome will open Atlas. You don't have to...
Okay, okay. Yes, you're right, you're right.
But
Mhm.
If you want the Odyssey one, then
No, this is fine.
Odyssey one will work too.
Okay, so this is what Atlas looks like. I've already defined this cohort, so I can actually just go look for it. It's the only cohort on my box. This cohort will not be on your box, so you'd have to go and define it for yourself. But just like in the PowerPoint, we can define our concept sets. And actually what's nice is I can see all my concept sets here. So before we were saying a concept set like warfarin, we had that ingredient concept ID. And the way that looks here is I'm saying I want warfarin, but I want all of its descendants. And that's essentially the same thing you were doing, writing it in SQL. Then once you feel comfortable with the way you've defined your cohort, there's a generation tab. And this is where you'd hit generate, and you'd be able to actually see the results. And we already saw that we were able to match our number. Any questions on Atlas? I know it's like really simple view of it, and it probably takes its own training course, but it is there, and it is an important part of our research. So thank you guys so much for your attention for Data A. You guys did really well. This is like drinking from the fire hose, trying to consume all this information. And I'll tell you personally, I've spent years working with the vocabulary, and it's taken me some time to learn how to navigate through it efficiently. So don't feel bad if you don't get it the first time. And same with the CDM. It takes a little bit of time to think about your data differently than you're used to with your raw data. But the benefits of that is that once you do the standardization, it makes doing this cross-collaboration easier. You can start to leverage the tools that they're talking about in a lot of the other trainings that you wouldn't be able to do within your own raw data. So earlier today, George talked about how OHDSI is a journey. And so we've learned about that. We started as OMOP, and now we've moved to OHDSI, and that our common data model, like Claire has talked about, is constantly changing. And do not be afraid to say what you see, and we can make and improve it. That's what we want to do as a community. We learned, Christian talked in depth about the vocabulary today. And so we understand now that it's important to our CDMs to use the standardization. That way we can all be speaking English. And we can talk to each other's databases in a uniform way. And then the same thing with the common data model. Giving our data that standard structure is important so that we can write these generic queries and ask different data sets for that same information. So if you can now imagine a situation, if I want to find how many exposures of warfarin do I have in my data network, I can write that query and share it with my friends and quickly get back answers. If everybody was playing in their raw data, everybody would have to be thinking about, well, how do I write this query? How do I get this? So the time to getting these answers greatly gets increased. So I also want to say, I know everybody here is playing at different levels of experience. And so I hope even if you're not going to be an ETLer, and even if you're not going to be a programmer, but you're still going to be interfacing with OHDSI, I hope this gives you the building blocks to think about the data in a way so that you can ask better questions or use the methods in a better way or understand why the vocabulary is important. So I hope you guys found it valuable, and we do want to play a little game with prizes, so I hope you guys participate. So I don't know if everybody knows what Family Feud is, but it's this I guess, wonderful TV show that's been in America for a very long time, where they go out and they'll say, they're going to ask a question of the public. They'll say, like, what is your opinion about this? And then the public gives answers, and people on the TV show try to guess what those answers are. So in this case, the tutorial faculty said, what were the important things that we learned today? So we would like you guys to tell us what you think you should have learned today in today's class. If you get an answer right, you will get a prize. So I hope you guys choose to participate. So, so we could just get started. Do we have the? Yes. Okay. So anybody have a guess of something we learned today? What about the OMOP model? Yes, we win a prize. The CDM standardizes a structure. Okay, let me tell you about the prizes. So there's no OHDSI swag. So what happens when you get Claire, Mui, and Erica, and Rimma on a phone? You choose to pick the cute thing as a prize. And so we picked Pusheen mugs, since Pusheen was our mascot for today. Maybe next year we'll have some OHDSI swag. Okay, so anybody else has some ideas about what we learned today?
It was originated under OMOP with independence.
And where is it now?
It's OHDSI.
Yes, you win a prize. Okay, that's what George taught us this morning, that we were OMOP and now we're OHDSI. And that gives us a lot of benefits because we can do a lot more research, and our community's grown a lot since then. So any other thoughts? You win a prize. It is a patient-centric model. CDM is patient-centric, and so all of the data in the CDM is basically anchored off a person. And we got one person in the person table, one record per person. Any other thoughts? It's concept-based. That is true statement that you could get the SQL code from Atlas. It was not one of our top things. No.
We learned the difference between concept code and concept ID, as Christian said.
Vocabulary only has one standard. One standard per concept.
We could give it to you. Oh my God, Christian. Okay, OMOP vocabulary. I'm stretching it a little bit here. OMOP vocabulary is used to standardize your terminology. So yes, we have standard term. We all want to be speaking one language, and that's the point of the vocabulary. I heard something about source data.
Data from different sources converted to one.
Yes, yes. Prize has been won. Okay, CDM can be used for different types of data. So it's not just claims. It can be EHR. It can be survey data. It can have your lab data in there. So we have yet to find data that we cannot stick into our common data model. Yes, you win a prize. Source data is still preserved in the CDM. Very good. Okay, you guys, there are only 2 more prizes left.
The mappings are preserved as well. Maybe not as important, but have the source concept and the
Yes, that is a true statement. Not on the Family Feud. Huh? The concepts are extensible. We improve the vocabulary all the time. That is true. Not one of the prizes. What, Vivian? CDM is standard?
OMOP model is lazy. You extract a lot of information from other people.
You guys are almost there. How about what tables are in the vocabulary? What table helps you get to all your concepts? What's the one that does all the relationships? Who said that? You win the prize. Okay. Concept ancestor table helps you find what you're looking for. So the concept ancestor table helps you traverse all the relationships at once. So we have one more prize. I'll give you a hint. Something about OHDSI. What kind of? It's open source. Oh, okay. So thank you guys again. I I hope that you guys got a lot out of this. Again, you guys will get all the materials. You get to keep the Odyssey in the box so you can play on your own if you don't have your own stuff at your own place. And feel free to ask us questions after the course. But unless you want to say anything else, that's it for today. So thank you guys so much. Thank you.